Okay, the last learning target for Unit 2, Part 3 is solving absolute value equations. This learning target will have its own separate quiz. So make sure that once you complete the notes and your task that you look over the information really well before moving on to the quiz. Now, with solving absolute value equations, we need to think about one, what are absolute value symbols? Let's remind ourselves of that. So absolute value, remember, if I'm taking the absolute value of, say, -6, those are my absolute value symbols. The absolute value of -6 is 6. Absolute value is the distance from 0. So if you were to draw yourself a number line and count backwards until you got to -6, you would make 6 steps. So absolute value is considered always positive, but keep in mind that it's distance. Distance is never negative, so it is always a positive answer. And that's one thing that we're going to look at whenever we are dealing with our equations. So let's talk about something that's really important to keep in mind when solving equations. You must isolate the absolute value sign first. You have to do that. You will get all of these equations wrong if you are not isolating your absolute value. Now, what that means, we're not going to move anything within the symbols. So whatever's inside the symbols, we're not going to move that. The only thing we're going to move are the numbers that are outside or around our absolute value. Okay? Now, they have to be on the same side as my symbol. We're not talking about the things that may be on the other side of the equal sign. On the side with your absolute value, we have to move all of these numbers that may be around the absolute value symbols. We have to isolate the symbol first. So let's look at example 1 and look at what we're talking about here. We want to isolate the absolute value. So what I'm going to do, I'm going to highlight my absolute value. And in this case, the only thing that's in the absolute value sign there is just an X. So I'm not real worried about the X just yet. The reason I highlighted that is because what I'm trying to tell myself is don't move any of this. Don't touch the absolute value symbol or the X inside. Move everything that's outside or around my symbol. Now, here's my equal sign. One thing I've noticed some people doing is they're giving themselves like a dotted line to remind themselves that I have two sides to this equal sign. I have the left and I have the right. Okay? On the left-hand side is where my absolute value symbol is, but I also have a +2. On the right-hand side, I just have a 9. So on the left-hand side, this is what I'm trying to solve for. So what needs to be moved? Don't move the 9. It's already over here. It's already away from the yellow. Don't move the 9 because then you're crowding this side, and that's not what we want to do. These are things to also think about when just solving your the equations or inequalities. All right, so back to our absolute value though, we want to isolate what I've highlighted here. So the opposite or the inverse of adding 2 would be to subtract 2. So if I subtract 2 from the left-hand side, I must subtract 2 from the right-hand side. And again, the people who are using this dotted line, it's just to keep them lined up so they remember I have to do the same thing to either side of that dotted line. Alright, so a +2 minus 2, I can mark that out. And so I'm just left with the absolute value of x equals, and then 9 minus 2 is 7. Now, you have to think about the fact that when you're dealing with absolute value, you're talking about what numbers or numbers has a distance of 7 from 0. The distance from 0 is absolute value. So let's set up a number line and let's just think about this real quick. Here's our 0. Well, there's two directions I can go. I can go to the right and I can go to the left. So let's count 7 places. Let's hop 7 places. Here's 1, 2, 3, 4, 5, 6, 7. I didn't make my number line long enough. Let's fill that in. 1, 2, 3, 4, 5, 6, 7. Well, that should make sense. 7 is a distance of 7 from 0. So 7, x equals 7 is one of my answers. The inside of my absolute value could be 7. Absolute value of 7 is 7. But let's go to the left. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Now this isn't just a 7, this is actually negative 7 because I went backwards. Negative 7 is also a distance of 7 from 0. So, or x could be negative 7 will finish out our answer. And you can always plug this back in to make sure. If you put negative 7, because x is negative 7, if I put, instead of an x here, if I put negative 7 in there, what is the absolute value of negative 7? Well, the answer is 7, so I know that I have the right answer. A lot of times you will have two answers for your absolute value equations. Now, they won't always be one positive and one negative, but you will have, for the most part, two answers with absolute value equations. Now, if you're asked to graph, I'm just going to put a dot at negative 7, and I'm going to put a dot at 7. I don't shade anything. I don't shade from negative 7 to 0 or anything like that. Those are the only two answers. So I only have two dots on my number line. And again, to check your solution, this would be my check here. Like I said earlier, plug in 7 in place of x, and that will give you 7. The absolute value of 7 is 7, so that does work. And then plug in negative 7 for x. What's the absolute value of negative 7? Well, that is 7, which does equal 7. So again, that works. Okay, so results, your graph, and then checking your solutions. What I want you to do is I want you to do those three things for this your term problem. What are the solutions to this one? We're solving for n. Make sure you graph it, and then make sure you show your check for your problem. Now, we're going to look at some that get a little more difficult, so let's talk about what we're doing with these absolute value equations. This is just a key concept for you to look at here. Notice that it says if the absolute value of A, so whatever number you have, is equal to B, B has to be greater than 0. Remember we talked about that we're talking about our positive numbers. If we're talking about the distance from 0, we've got to have, distance is always a positive. This is how you're going to solve it. You're going to take the expression inside the absolute value and set it equal to the positive, okay, whatever the number is. And then you're going to take that same expression and we're going to make it equal to the negative. That's exactly what we did for our solution on number 1. We took what was inside the absolute value and set it equal to the positive, okay, positive 7. And then we took the expression inside, which is x, and we set it equal to the negative. Okay? Our solution for this one was exactly what this key concept is talking about, taking what's inside and setting it equal to the positive and the negative possibility. Okay? Now, the reason this is important, it's very simple like number 1, but when we get into problems like this one, this is where we start having a little more difficult absolute value equations. Now this one is in a word problem format, but I will tell you, just looking through here, you should automatically see your absolute value signs. So they've actually given you the equation. You're not going to have to write the equation. What you have to be able to do is plug in numbers and solve. Okay? So let's read through this and let's see what this problem is telling us and asking us. Starting from 100 feet away, your friend skates toward you and then passes by you. Okay, so this is what I'm thinking. You get to see my beautiful drawings here. Here's me, and here's my friend, and she starts skating towards me and then passes right by me. Now, we're starting 100 feet away from each other, so the distance from me all the way to her is 100 feet. Now notice when she starts skating, this 100 starts getting smaller and smaller and smaller until we finally reach 0 because she's right at me. But then she passes me by, so she's going to continue on. Alright, so she skates at a constant speed, so she doesn't change her speed, of 20 feet per second. Her distance, d, from you in feet after t seconds. Okay, so let's think about what this means. Her distance, we're using d to represent that distance. Her distance from you in feet after t seconds. Okay, we don't know how long she's skating. Okay, it's given by this formula. Now, let's understand this formula just a little bit, this equation. 100 is where she started from. She's 100 feet away from me. And she's going to get 20 feet closer to me every second. That's what 20 feet per second means. So after 1 second, she's going to be only 80 feet away from me because I take 20 away from that. After 2 seconds, I'm going to take another 20 away. So she's 60 feet away from me. So I'm subtracting 20 feet every second. But she doesn't stop at me. Otherwise, we would just be at 0. There wouldn't be a distance because she would be right next to me. She keeps going. So I'm going to keep subtracting 20 feet, but is she actually getting into negative 20, negative 40, negative 60? Well, no, she's not because distance isn't negative. We've just reached our 0, and basically we've started over again, and we're trying to figure out how far away is she now from me once she stops somewhere back here. So that's what our equation is telling us. Now, what it does tell us is at what time. At what time? That probably should just be time. At what time is she 40 feet from you? Okay, so what this tells me is that our distance is 40. Remember, D stands for distance. Our distance is 40. Our T is the question. At what time? We know the distance. We know the D. What we don't know, we know the distance. What we don't know is T. Well, we have, and I'm going to circle it, we have our equation, so let's fill it in. Since we know the distance, 40 feet, we're going to plug 40 in place of D. And I'm going to rewrite my equation here. And I have to leave that as minus 20t because I don't know the time. So that's what I got to solve for. Now, back to what we did in problem 1, I said you have to isolate your absolute value. Well, look at your absolute value. If I were to highlight this, would there be anything outside of the absolute value symbols? And there's not. Now keep in mind that 40 is on the other side of the equation. So I'm not worried about the 40 right now. There's nothing outside. There's stuff inside, but there's nothing outside of that absolute value. So I don't have to move anything, and that's nice. What I'm going to do is I'm going to go back to my key concept. I'm going to take what's on the inside and set it equal to the positive, and I'm going to take what's on the inside and set it equal to the negative number. So this is what it's going to look like for problem 2. Everything on the inside of my absolute value, 100 minus 20t, and I'm going to make that equal to positive 40. Then I'm going to do the exact same thing. I'm going to take what's on the inside of my absolute value, 100 minus 20t, and I'm going to set that equal to the negative. That's exactly what the key concept told us to do. Set the expression on the inside equal to positive 40, set the expression on the inside equal to negative 40. So now I just have 2 separate equations to solve. Okay? So this is a positive 100. Inverse would be to subtract 100. 100 minus 100 is 0. Negative 20t equals 40 minus 100 is negative 60. Now be careful. Notice that I brought my negative sign down with my 20. Don't accidentally lose that. And then to break these apart or to split them sounds like division. That's exactly what you're going to do. Divide both sides by negative 20. So negative divided by negative is a positive 1t. And negative divided by negative, 60 divided by 20 is a positive 3. All right, now that's this equation. We need to solve for the second equation here. Okay, so same thing that we did over here. I need to subtract 100 from both sides of my equal sign. So this gives me a negative 20t again, but this time I have negative 40, negative 100. I'm down 40. I'll go down 100. I'm actually down 140 this time, so be careful with your subtraction. And then again we're going to divide by negative 20 to break that away from the t. So negative divided by negative, this is a positive 1t. And a negative divided by negative, we've got 140 divided by 20 is going to give us a positive 7. Alright, so my solutions are 3 seconds and 7 seconds. So I guess I was right in putting times. I thought I had a grammatical error there, but there are 2 times there. 3 seconds and 7 seconds. Now the reason why is because at one point she is going to be 40 feet from me in this direction. That's only going to take her 3 seconds to get here, but then she's also going to be 40 feet away from me back here, and from start to finish that's going to take her 7 seconds. So coming towards me at one point she's going to be 40 feet away, that's 3 seconds, but then once she passes me by she's going to have another, she'll be 40 feet from me again at some point, but that's going to take a total of 7 seconds. So 3 seconds, let's put our units on there, and 7 seconds. Alright, so take this example that we just did with absolute value and apply it to this your turn problem. Same basic problem, you've got pretty much the same information. There are 3 questions in this your turn problem, so please make sure you answer all 3 questions. And I discussed in problem 2 what these 2 numbers represent from problem 2. They're the same thing here in the your turn question. Alright, now let's think back again. Let's recall. We've talked about this already. Absolute value represents the distance from 0, and distance is always non-negative, therefore it's going to be positive. So if you have an absolute value equation that states the answer will be negative, it has no solution. There's no way to take the absolute value of a number and get a negative solution. So let's look at problem 3. We're kind of mixing in everything we did in problem 1 and 2 all at once here in problem 3. So I am going to highlight my absolute value. Here's my absolute value symbols, and here's everything on the inside of my absolute value. So what I'm highlighting, I do not want to move. Okay, I have to isolate the absolute value. That means I've got to move everything away from it. So if you look at your absolute value symbol, even if I were to cover it up, on the side with what I highlighted yellow, what I have covered up is a 3 and a plus 12. These 2 things have to go. I've got to move them over here with the 10 because I have to isolate what I have here. So just like you would if this were just one big variable right here, if you thought of this as just a big X, you're multiplying by 3 and you're adding 12. So we have to go in reverse. So instead of adding 12, we're going to subtract 12. Now don't try to subtract 12 from the inside. I get that a lot. People try to do outside and inside. We're still doing this side of the equal sign, which is the left-hand side, and moving it to the right-hand side. I'm just moving what I have not highlighted. So the opposite of adding 12 is subtracting 12. If I subtract 12 from the left, I have to subtract 12 from the right. So what this will leave me with is still the 3, and then the absolute value of 2z plus 9. Again, I am not moving the absolute value, and that equals 10 minus 12 gives me negative 2. I am not moving the absolute value, just everything away from it. So again, the 3 was not highlighted. If I'm multiplying by 3, because notice this is side by side. Anytime you're side by side, it's multiplication. So the opposite of multiplying by 3 would be to divide both sides by 3. 3 divided by 3 gives me 1. So I have isolated my absolute value. That's the only thing that I have left on this side, and that equals, now if you do negative 2 divided by 3, you're actually going to get a decimal, and my suggestion would be not to write it as a decimal because it's going to be repeating. Just leave it as the fraction negative 2/3. I would do that, because if you don't, then you're going to wind up with some really awful decimals out here. So leave them as fractions. Alright, so notice that we've isolated our absolute value. We've gotten the absolute value by itself. Okay? There's stuff on the inside, that's okay. There's nothing on the outside. But what we were talking about up here is that when you take the absolute value of anything, no matter what you have in here, if you take the absolute value of it, it has to equal a positive number. And if it doesn't, in this case it doesn't, it equals a negative number, then you don't have to do anything else. There is no solution. This is your answer. I have people that will take 2z plus 9 and set it equal to negative 2/3, and take 2z plus 9 and set it equal to positive 2/3, and they get answers which are there on the multiple choice. However, there is not a solution to this. If you were to plug those answers in for z, you would not get negative 2/3 for your answer. You cannot take the absolute value of anything and get a negative number. If you happen to get a problem like this, you've isolated your absolute value and it still equals a negative number, then there's no solution. You do not have to do anything else with that problem. Alright, so take problem 3, do your turn problem 3. Make sure you isolate your variable first and then solve it there the rest of the way, if necessary. Alright, so here's our summary. We're just doing the absolute value equation, so if you look in your book, you do have absolute value inequalities, but we're not doing those right now. Right now we're just focusing on the equation, so for your summary, I want you to answer 1A and 1B. Just solve each one of those for n or t. Make sure you isolate the absolute value first, if necessary, and then break it apart using the key concept box, where we take what's on the inside and set it equal to the positive, and what's on the inside you set it equal to the negative. And then also make sure you read question 2. It's a yes or no, or well, it's a kind of a yes or no question, but you give me an answer and then make sure you explain it. So you're not writing yes or no. It's just one of those things where once you give me your answer, then you explain to me why you believe that.